The brief we have been given is very wide, and I cannot do all of it, so I'm going to do some little bits. I'm going to say a little bit about the power of science, how strong science is, how useful science is, and I am going to say a little bit about where authority and power lie in science, particularly in research science. And I have some slides which I hope will help, because I have a rather curious English accent, British accent. I am an astronomer, and so I am used to working with big things and very distant things. And to me, immediately, the power of science is revealed when we realize that we can study distant galaxies, millions of millions of millions of kilometers away. And we can study stars in these galaxies, because each galaxy is typically 100,000 million stars. And with the equipment we have today, we can study the chemistry of these stars, we can study the way they are moving, we can study the way they are grouped. I think for this one I will leave it running so it does a number of loops. Up in the top left-hand corner there is a date, starting 1995, going through to 2010. And each of these circles is a star. It's actually a star observed with infrared light, but that doesn't matter. And the video is made of a whole lot of still photographs put together, and you can see the way stars are moving. These are stars near the center of our galaxy, where there is a big black hole. And the way these stars move show that there is a black hole. Here, there is something with very strong gravity. It makes the orbits of the stars curve. It bends the orbits of stars. If you look particularly at this star with the yellow orbit, it goes round. It's this one. Watch it as it moves. And also this one. Watch it as it moves. Sorry, that one. Normally, stars should move in straight lines, unless something tugs them. And here, in the middle of this picture, there is something that we cannot see, but has lots of gravity, and is tugging the stars to go round in curves. And we understand there is a black hole there, right at the centre of our galaxy. It has a mass of maybe 10 million times the mass of our sun, which is pretty big, but actually compared with some other galaxies is not so big. But with fairly simple science, we can study that as well. Science also lets us study tiny pulsating stars. These stars are 10 kilometers across, and they are at distances of hundreds of millions of kilometers away. And so good is our science, we can study these. Those are just a few samples of the power of science. And it's very exciting, I enjoy it hugely, but it doesn't work everywhere. Science does not reach everybody. Many people do not understand science, are scared of science, and cannot tell what is good science and what is crazy science. One example is there is a scare that the world is going to end next year, 2012, on December the 21st. Just after 11 o'clock in the morning. And there are many reasons given for this. I've picked just one. It's because all the planets are in a line and they're going to pull the Earth and maybe tear it apart, and it will be the end of the world. The planets are not lined up like that in 2012. The next time they will be lined up like that is 2040. Even if they were lined up like that, it would have no serious effect. It would make the tides in the sea a little higher by 0.5 millimetre. It will not end the world. And there have been occasions in the past where the planets were lined up and nothing happened. So why this crazy science? Actually, there are often scares about the end of the world. 2012 is the next one, but there'll be another. 2015, 2016, I don't know. There'll be another. And it is a bit like some of the other science scares. The ones that we are aware of in Britain is people are scared of genetically modified crops. We eat seedless grapes, but that doesn't count. There are people scared of some vaccinations and inoculations. And small children have not been taken to the doctor for their inoculations because people are scared. There's a lot of misinformation about HIV and AIDS. And there's a group of people who do not accept the climate is changing and are doing their best to contradict that. You may have seen that there's been a fresh release of some hacked emails just before another major climate change conference. And for these people, rational arguments don't work. Scientific arguments don't work. And I think that applies to quite a lot of people, and we need to remember that. So science is also powerless as well as powerful, or maybe those of us who are trying to explain science are useless. Power in science. Is there power in science? Who has the power in science? I think the same question is, who has the authority in science? Who is respected? Whose word counts? Well, the quick answer is, of course, in research science, it is the data that matters, the results. And nothing else matters, does it? That's absolutely black and white and clear. It's the data. Full stop. Period. I don't think so. I actually believe that one's colleagues, the peer community, matter enormously, and I'll explain why. Recall that I am an astronomer. Astronomy, geophysics, archaeology, they're sciences, but they are observational sciences, not experimental sciences. You cannot go to the star and turn the knob and see what happens. You cannot say to the rocks, please will you fold again? I want to see what happens. You cannot say to the skeleton, please can we rerun your death and burial ceremony because I want to see what happens. You cannot do any of those things. You have to work with what you are given. Other kinds of science are experimental. You can do experiments. You have more control. I mentioned black holes earlier. One very good example of this process in astronomy is when we found what we thought was the first black hole in the constellation of Cygnus the Swan, one that's sort of up there at the moment. Some astronomers picked up some peculiar behaviour of a star. The simplest way to explain it was to say that the star was twinned with a black hole. Many stars are in pairs, they go round each other. This one was an ordinary star and a black hole. And everybody said, oh, a black hole? I'm not sure. Maybe it's not 2 stars, maybe it's 3 stars. No, that didn't work. Maybe it's something else. No, that didn't work. Maybe it's a problem with... You try to check that out. No, that doesn't work. And for 10 or 20 years, we tried to find ways of explaining this thing without invoking a black hole. And after 10 or 20 years, we gave up and we said, oh, I suppose it is a black hole. That's not proof. That's a community decision. Oh, I suppose it's a black hole. Your community, your scientific community, your peers are very, very important. If they will accept your crazy idea, you're okay. You will get a position, you will get money, you will get your papers published. But if they do not accept your crazy idea, you have no job, no money, and no publications, and no time on the telescope. And because it's a community decision, it involves judgment, discernment. And communities can have fashions, what in English we call bandwagons. Everybody thinks, oh yeah, it's a black hole, and off we go. And the one poor soul saying, no, it's not a black hole, it's they are ignored. And because it's a community effort, I think there is a risk that minorities get ignored, that minorities suffer. And in astronomy in Britain, the community is white men. So the minorities are people of colour and women. And that's more than enough from me. Thank you for your interest.